I got my first gold medal, and that was such a special moment. So even the CEO of Kaggle, he reached out to me and he said that they really found my notebook not only interesting but knowledgeable, because they were able to reflect back on it to see why there's such a big gap between female Kagglers and male Kagglers.
All right, so hello everyone, and welcome to the AI Stories podcast. I'm Leiser, I'm a data scientist at Iwoka, and I will be your host. So today, our guest is Parul Pandey. Parul comes from an electrical and electronics engineering background. She did a master in this subject. She had a few experiences, but at some point she actually transitions to the world of data science and machine learning. She worked as a data scientist at H2O.ai. She worked as a machine learning engineer at Weight and Biases, and she's now back to H2O.ai working as a principal data scientist. On top of this, Parul also wrote a book on machine learning for high-risk applications, and we're going to talk about this in this episode. And she is also a Kaggle notebook grandmaster, and we will also talk about Kaggle, of course. So if you enjoyed this episode, please subscribe to the AI Stories YouTube channel, leave a 5-star review, comment, share the episodes, do whatever you can to help the podcast. All right, let's start now. Hi, Parul. How is it going?
Hey Neil, glad to be on the podcast, and thanks a lot for having me here. I'm doing pretty well.
Yeah, my pleasure. Great to have you all the way from India. First thing I want to ask is, well, I mentioned in the intro that you've made this transition from electronic and electrical engineering to data science. So can you talk a bit about this? How did you get into the world of data and AI?
Yes, this journey has been a pretty interesting one, so to say. So, after I graduated, like you said, as an electrical and electronics engineer, the automatic choice for me was to join an electrical company, and I did get into a power distribution utility in India.
Mm-hmm.
And interestingly, there I was working with electronic meters data. So there we had to analyze the data coming from the consumers, and our task was to identify special patterns in that data. So let's say if there are people who are indulging in some thefts, or there are faults in the meter, and so proactively, if we could point out those stuff, that would definitely help the company. Now, at that time, even though we were working with a lot of data, there were some specific softwares that we were using for it, and those were being supplied by the electronic meter manufacturer. So that way we were tied because we had some specific softwares to work on. We couldn't work on those back home because the access was limited to office. And so it was during that time I was discussing about this with one of my friends, and I told about, look, is there some other way where we can analyze all this stuff in a bit more easier way and a more efficient way? And so there it was when I came across this field of data science, and I saw that there are actually a lot of open source tools, and I actually came across the language R, so the statistical language. And I just sort of opened a, you could say, Pandora's box in a positive way, because I started looking at the value of data and then munging that data with a lot of tools that are available. So I started diving into it, and then I thought, is there a programming counterpart to that? And I had some background in C, so I was looking for similar options, and then I discovered Python, a language which again was so useful for data science. And then it was sort of a research that I started doing on my own, and from there, like as you say in a very cliche term, rest is history. So I then left my job there because I was so much enthralled by this entire world of data science. And then I started studying on my own, refreshing my topics. In fact, I to refresh my programming skills, I went back and did CS50, the whole course online again. And yeah, and just from there, then it was learning, relearning, uh, getting asking for help from the community, and so on.
So you left your own job to basically go back to study data science and get into the field. Was this stressful to leave your job and start to, well, get back to something new and start learning a new field from basically from scratch? Well, not from scratch, but yes, from the beginning.
Yeah. So the funny thing is, I think that was the only part of my life prior to working as a data scientist, which was not stressful. Because I think for the first time, I sort of realized like this is what I'm really enjoying. And also, I just became a new mom that time. So I was looking at excuses to actually leave job. But like a person I was, I just couldn't take this risk of, okay, just leave the job. So when I became a mom, then I had a reason. Okay, I want to spend time with my baby, and also, so studying was another part of it. So that like helped me to take this decision of leave your job. You have nothing at hand. Never mind. But I was very excited to study, and also I think at that time the whole thing concept of MOOC was taking on. It was you suddenly had like great professors from all around the world online giving lectures, and you are at one part of the country, one part of the world, and you can access courses from, say, professors at Stanford and Harvard. So that the whole concept for me, it was so good, because back when I was doing my graduation, even though internet, we used to go to internet to for some resources. Most of it was library, so we had to go to library and search the books manually and then
Hmm.
make notes. But this whole concept, wow, this is professor is teaching in Princeton and this is in Stanford, and you can access the course, you can give online exams. So that was taking up, and I think that was something, the whole democratization of knowledge, so to say, was happening at that phase, and that sort of really caught me.
And so at what point does Kaggle play a role in your journey? I guess you start learning about data science, you start to get into the field, and then suddenly you start to go on Kaggle. Where does this play a role in your career?
So Kaggle does get a fair share of mention in every online course that you do or talk to people. For me, it was just accessing data sets from Kaggle. That's all. In fact, I created my account long back, but the only thing that I used to do was to go there and download data sets, because I was under the impression that, it's only a platform for machine learning competitions. But when I came to H2O, I was suddenly surrounded by a lot of Kaggle Grandmasters. And when I started talking to them, I realized that there are other tiers or categories also of Kaggle. And you might choose the one that you are more like passionate about. Even though I consider the competitions to be the most toughest category, because there you literally compete with hundreds and thousands of people. But I started enjoying the notebooks part, because that was the part where I would put my code down and people would look and refer to it, provide feedback. So for me, that was something that was really enjoying. So whenever a new competition would come up, I would I would do some exploratory data analysis, and then I would put my notebook, and then people would like it. And so once you start getting medals, then you start thinking, okay, so there are 15 gold medals you need. Let's get to them. And so from there, I think it took some time, but that was the time when I actually joined H2O and when I started talking to my colleagues. So that was that point.
Okay, so first you learn about data science on your own, then you join H2, you encounter colleagues who go on Kaggle, you decide to discover Kaggle yourself, and you start to play around with some data sets in a notebook.
Yes, yes, definitely. That was actually the path I took.
Okay, and so to put things into context, there are different parts of Kaggle, different things you could do. It's well known for its competitions where you have a data set and you need to build the best model with, for example, the highest accuracy or optimize any metric that's out there. But you decided to take another path, look at data sets, visualize them, and then share your notebook with the community?
Yeah, so actually why so my first, I think not my first, but my second or third notebook. So what why I went that path. So Kaggle organizes a data science survey every year, and they put out that survey to people out there, and the data set that they collect, then they open it up as a competition. So what you do is you see that data and you analyze. So everybody analyzes it, and it's a competition. It's an analytics competition, and people put down what they think they understood from the survey. So in 2019, I put out I think it was my second or third notebook. It was on women's representation in Kaggle. So from that entire survey data, I took out that part and I analyzed whether the women's representation was increasing or decreasing. And I found that for the last 3 years, it was just static at 16%. That was in 2019. I'm not sure what it is at this moment. And when I started analyzing the data, I went further. I analyzed it country wise, region wise, income wise, if they're getting the same income, the female data scientist as compared to the male counterparts, and lots of it. And this was such a hit amongst everybody. I got my first gold medal, and that was such a special moment. So even the CEO of Kaggle, he reached out to me and he said that they really found my notebook not only interesting but knowledgeable, because they were able to reflect back on it to see why there's such a big gap between female Kagglers and male Kagglers. And so that time I realized, like, it's just not a platform for just downloading data set. There's a lot more to it. You can take these data, the real world data sets, and you can actually create some meaningful work out of it. And after that, so these are specific analytics competition, which are like end-to-end competitions where you don't have a metric to optimize, or you don't have leaderboards. You just are given data and you're supposed to analyze and come with some conclusions or points. And so apart from just exploratory data analysis, these were the other competitions which I really liked.
And so, how do you become a Kaggle notebook grandmaster? How does this work? Because there isn't any metric to optimize for. So, yeah, how does this work?
So for a notebook grandmaster, in fact, notebook. So there are four categories right now. One is competitions, and then there is notebooks, data sets, and discussions. So for all these three categories, the community votes for you. They upvote. And for a notebooks, you require 15 gold medals to become a Kaggle Grandmaster, and you get a gold medal when 50 you get 50 votes on a single notebook. So it's the community actually. So you put out your work to the community, they like it, they vote it, and then you add the votes, get based on those votes you get medals, and once you get 15 medals you become a grandmaster. So it's an ongoing journey. It's like I'm not very active now because I've been fully immersed in the book. So
Mhm.
it's a break I've taken. But of course, once it gets over, I really like to go back and start. Because this gives a chance for you to work with the community, amongst the community, get the feedbacks, learn with them, take their ideas, and see what's going around in the data science field, what's new, what new methods people are using, etc.
What's your advice then to make useful and good analysis based on data? Like you mentioned this task where you analyze data from Kaggle and realize that the number of women wasn't increasing. What would be your advice for incoming data scientists to, well, drive value out of data?
So my advice for anybody will be, whenever you work on any project that's concerned with data, I think the first and foremost thing would be to just sit back and look at data, like not literally look at it, but make sure the data that you have is firstly, you've thoroughly explored the data before going to the modeling phase, and just jumping onto the models and picking the best model. I think if you spend 80% of time on data cleaning and wrangling, a lot of work is already done. This I'm speaking from the industry point of view.
Mm-hmm.
I'm not, of course, from the Kaggle competitions. So in real life in industry, a lot of work gets done if you spend like more time on you cleaning your data and wrangling it, and then from there you start analyzing. And of course, now because I've written a book on high risk applications, it's also even more important that you firstly look at data clearly to see it doesn't have any biases or things before just creating a product and just productionizing it. So data is the central thing, and I think today a new paradigm is coming out called data centric AI, as opposed to model centric AI, where people are asking to give more, like lay more stress on the data part than on the models part. So data still holds the reins.
So it's interesting because Kaggle competitions, it's basically a model centric competition, right? The data set is often given to you. Do you see a world where we would move to a data centric competition where basically you're not given the data, or you're given the data partially and you need to process the data set or come up with the best data possible to then build a model and then optimize a metric?
I think if that happens, that'll be really good, and probably someone somewhere out there would be working on that, because it's also very important to highlight the importance of data. And I think slowly, I think at one point of time there was a lot of saying about how the answers or the solutions that you get are dependent on the models. But today again, there's a shift again when people are saying no. Data still is the number one priority for a project that you should have. And I think for some of the competitions in Kaggle, they allow external data. So they allow people to bring in external data under some rules, where people then get data, publicly available data. People bring that also. But I definitely see a competition where people would be getting data themselves, or let's say curating data, cleaning data, labeling data themselves, annotating it, because these are the most hard and monotonous
Mm-hmm.
tasks that nobody wants to do. But I think definitely if you label or annotate or work with your data, you'll definitely get better results with simpler models, I believe.
So yeah, you mentioned actually two very interesting things. The first thing is you mentioned that to begin the analysis, you need to look at the data. And I think there are a lot of people who just start by, well, they get the data set, they don't even look at the data, they want to train a bunch of models, they try simple models, deep learning models, and then they hope for the best. They hope that their metric is going to be optimized, or they hope that something magical is going to happen. But yeah, as you said, 80% of the task or of the work is on data, and you actually need to first understand the data, dig into your data, visualize it, create features, and if only after that you can start training a model and optimize it. But if you don't look at the data and don't try to understand your data, you're not going to be able to create a very good and useful model.
Yeah, I mean, I think any data scientist, any product that we create, ultimately it goes in the hands of people. I mean, we create products so that people can use them. I mean, we don't just create products so that they lie in our systems, right? Or they never see the light of the day. So whenever anything has to go into the hands of people or a huge population, it really becomes important that the very first stage of your pipeline, gathering data, like not even working on data but gathering data, is also as important as any other stage, because they might have huge ramifications in the end if you don't lay enough stress on that part. uh, so yeah, that's the underlying part of like what you also said.
Yeah, and the second thing that I also wanted to discuss is that usually we see the data parts as the kind of more boring part, I would say, data collection, data cleaning, data processing. But I think, as we said, 80% of the work is on data, and it's only by mastering those boring tasks that you actually become a great data scientist. And if you don't want to look at the data, then I guess data scientist is not the right job for you.
Yeah, I think the real job is making sense out of data. So yeah, you rightly put that. That's definitely the boring part, but then if done properly, that adds a lot of value to your project.
So two questions on Kaggle that I have before we finish the Kaggle episodes. First one is, what are the pros of learning on Kaggle? Why should I go on Kaggle? Why is this useful compared to a course, compared to a book, compared to an individual project?
So first one I think is the access to real world data sets. A lot of, if I say MOOCs or online courses, uh, they give like they have toy data sets which are overly used data sets, but Kaggle has real data sets, which especially the competition data sets are the ones that companies they put there, real companies, and like it ranges from NLP text data to image data to time series data recommender. So you get a mix of every data, and that's real. Even satellite data is there. Second, you get exposure to many different sort of problems. So you have like many competitions that are coming out. So recently there was RSNA competition, and then recommender system competition. So you get access to, you can learn even if you don't want to participate. You can just read and understand like why this company is holding this competition, what is their idea, what is the metric that they're trying to optimize. Third, I would say is you get a lot of community support over there. So if you have any question, you put your question, you'll get thousands of answers there. People will reply right from the experts to beginners. I don't think that's really available on any other platform today. Uh, and then you can learn from the top performers. So people who at least reach in top 10, they usually put out their winning solutions on Kaggle, and just by reading them you get a lot of insight, like why did they use this method, and then you can also ask them questions. So that's really good. You get to learn what did number one did to achieve that score, and what I didn't do, what I could have done better. And also, finally, I think the availability of GPUs that Kaggle provides, GPUs and TPUs free of cost. Again, that's a win-win for anybody who doesn't have their own hardware. They can definitely use. So I think it's a great learning platform when you want to learn with the community, but you also want access to the most timely and best resources. Just that would be my 5 points.
Do you think you became a better data scientist thanks to Kaggle?
Um, I definitely networked with a lot of people on Kaggle. In fact, I would say I still haven't like met anybody of them. For some of them, I've not even. I don't even know how do they look like, because the avatars that they have on Kaggle, it's different. But yes, I did. I think when I used to analyze the data, then I used to go through the other notebooks of other Kagglers, and then you learn like, okay, this is a good tip, this is a good trick. This could be a good way to automate the script. So I have definitely learned a lot from Kaggle.
So you basically were at H2O.ai. This is where you kind of played around with Kaggle as well, became a Kaggle notebook grandmaster. Then you worked at weight and biases for a couple of months. You're not back at H2O.ai as a principal data scientist. Is that still right?
Yeah, I worked for close to 10 months at Weights and Biases.
And then on top of this, you also started to write a book, which I think is now finished almost, the a book on machine learning for high risk applications. I want to dive into this book, and the first thing I want to know is Why did you create this book? Why did you start writing on machine learning and AI for high risk applications?
So this idea actually originated when I had joined Weights and Biases. So this would be January of last year, yeah, 2022. Um, so I was interested in this field of responsible AI that is working responsibly, and so I started going deeper into it, and that's when I was little less active on Kaggle, and I started spending more time on the literature part of responsible AI, and not just from an ethical point of view, but also looking at resources or codes or libraries which are available there, which companies are working. So H2O also has their own responsible AI toolkit, both in open source and their enterprise versions. So while I was at it, I was approached by Patrick Hall, who is one of the co-author,
Mm-hmm.
and we started discussing on the aspects of if it was okay to write a book or is it possible to write a book. And that was an idea, and it did sound very difficult at that point of time. But after 1 year, finally we are done with it. Yeah. So I think it was three like-minded people. So James is another co-author of mine. So it was like three like-minded people who were interested in this aspect and come from different backgrounds. We came together and we thought, yeah, this is a good and timely topic. I think that we should now work on. Also, because at this time, there's a lot of hype around AI. Well, both for positive and negative reasons, but it's also equally important to now also showcase what might go wrong if things are not done properly. And we thought like it's a good time to write a book which could be referenced by both in the industry and both who are just incoming data scientists to also understand that if you are working in AI space, you have some moral obligation towards the people who are going to use it, towards the people whose data you've collected. So that was the idea, right? And slowly and gradually, I think we did finish the book.
So the idea that there is a big hype, that things are progressing very quickly, but you also want to say, hey, there are those high risk applications and we need to pay attention to those, because if we don't do anything, or if we don't pay attention to that, we can, well, things can go wrong basically.
Yeah, like the funny part of AI products is so there's no like so if like I always give an example of a mobile phone. So when mobile phones are created in factories, they undergo like hundreds and thousands of tests. So stress tests, like they're thrown from a height again and again. They are switched on and off again and again, just to make sure that when they come in your hand, they and the way you use it, and at least they don't break the very first day that
Mhm.
that you bring a phone. So our phones, they fall. We use them all the time. We never switch them off. But so a lot of things are kept in mind when you create things like mobile phones and other products. The problem is that in AI, we don't really think that much. It's like we just release the product, and if we find a problem that time, then we take decisions. Like it's like the people who are going to use your product, they are like the guinea pigs, so you experiment on them. If something goes bad, then you pull the kill switch, and then you that time you sort of say, okay, we made a mistake, we're going back. So there's a lot of I guess sincerity and honesty, I think, that you require at this time. Like unless and until you're 101% sure that your product is not going to discriminate or doesn't have anything, or is not going to perform the way you intend it to be, you should not release your product. So there are a lot of things that are going on, and so we've tried to showcase the ways in which you can try to sort of uh, debug your programs or test your products and things like that. But even so presenting technical approaches. We've shown given we've written about technical approaches to responsible AI, but this is such a sensitive topic because we also have to remember that socio-technical approaches are as important. So let's say if your team is not diverse at all and you're creating products for a diverse population, that doesn't work, right? If you have just a homogeneous workforce and you are taking and you let's say you're an all male team and you're creating a product for female, that doesn't work. So all these things are also have to kept in mind, but we've tried to sort of, you could say, show a
Mhm.
way, and hopefully people are going to benefit from this.
Why do you think that people keep releasing AI models that are not ready or that aren't great or even perfect, like a cell phone, for example, which has to be perfect? Why do people keep trying and releasing AI models that don't well that are not as good as they should be?
I think one of the reasons is we don't have such rigorous regulations, even though we do have some in place, but they are, I think, country specific at this moment. A lot of countries have no regulations in place, and then there is this culture of right breakfast and uh, just experiment and breakfast, and then you learn from this. So experiment, iterate, and then never mind, you go again. So that's a culture issue, I believe that is. And then I think a lot of competition in the space, so people want to just come up with things faster and to show, how with magic everything can happen, and you're so that's sort of a thing. I think why for the other industries today. So even if you see for mobile phones, the example that I gave, even if you get a defective phone in your hand, that won't matter, right? I mean, you go back and you can get it changed. But the problem is if you deny a loan to somebody based on the gender or the race, and there's a human at the other end, of course. So that is going to have a lot of repercussions. So why this decision? So you're using AI in almost all the products today. There's no product in which AI is not involved. And if you make an error, the margin of error is so small. There's a real human being who's the other side. But even we know this, right? People, you, me, and the other people who work in the industry, we all know that this is a fact. But I think it's about just going out there and bring out one product, second product, third product, because we are in such a cutthroat competition today. We want to sort of uh, I know just sell things fast,
Hmm.
and we also because no real regulations out there, so we always think, okay, if something wrong happens, we'll see that time. If a chatbot goes crazy, we'll shut it down, no problem. So because of things like that, if we are using AI algorithm for hiring, and if somebody points out biases in it, we're going to stop at that time. We don't have to worry right now. So mixture
Hmm.
of factors, I believe.
Yeah, that could actually be one reason why AI is progressing so fast. It's because so there could be some obviously there are some bad things like you release products which aren't ready, you might deny people for a loan based on their gender, which is obviously very wrong. But on the other hand, perhaps because people are releasing whatever they got, they want to learn quickly. Well, the field is progressing quite quickly because they fail, they release things that aren't ready, but at least they learn from those failures and they improve step by step. And so that could perhaps be a reason why the field is progressing a lot. Not a great reason, because obviously it will mean that some products are not as good as they should be, will have biases. But as every new technology, perhaps this is something that's needed in the short term. I don't know. I think the point that you mentioned about regulation is very important. Like, obviously, regulation have to come because if we have regulation, we don't allow this kind of releasing products that aren't ready.
There should be like progression is good. I think there are some real problems that of course, AI can solve and is solving also. But still, I think we should always think from this point of view that there's going to be a person, a real person, who can get impacted in a wrong way if something goes wrong. So have that thing, or a guideline or guardrails basically. um, a lot of work will then of course be simple. So if even before making a project you always put down things that, you know what, if something goes wrong, these people will get affected and this is going to happen, then automatically the way that you try to create things, or the way you picture things, they shift. So then you become very uh, like you become sensitive, right? So then when you make product, your products will still come out. It might take a little longer, but to ensure that it's tested
Mhm.
enough, you make sure that it has passed all the checkpoints correctly, and you're not in a hurry, because then you feel I could be on these. So imagine if I create a system for lending purposes, and then that system is used
Yeah.
upon me and I'm denied a loan. So I don't want to be there. So it's just, I think, guardrails should be in place right from the beginning. There should be people who should be appointed. I would say chief risk officers should be there in a company or in a project, who should be sort of responsible or liable for this. So
Hmm.
yeah.
Yeah, I think that's an important point. It's also important to distinguish high risk and low risk applications. Like if it's a low risk applications, we don't really mind, I guess, if the product isn't ready or if it's released, the product is not perfect, it's gonna fail, and we're gonna learn quickly. But if it's, for example, yeah, trying to make a robot work, for example, it's fine if the robot doesn't work well and we release the product, but yeah, there isn't any risk. Whereas for a loan or for medical purposes or things like that, in this case, it is a very big issue. If we release a product that is not ready, then yes, that's something obviously very bad. If you start to, I don't know, mispredict cancer to people, or if you start giving loans to, well, not giving loans to women or to some kind of religion or whatever, it becomes very bad. So I guess in the setting of high risk applications, you actually really need to have a great product before releasing it.
Yeah, especially for healthcare and financial and lending industries, it's even more important to have guardrails in place, or using AI more responsibly. And there's a complete website called AI Incident Database, which highlights all the recent and the past AI things that have gone wrong. And it's a complete catalog of incidents, as I think, as you could say, recent as I think February of 2023, where they've given all examples of like what went wrong and what was wrong, and how the algorithm was picking up on features and signals that was discriminatory. And it's a good example to read them and understand. And if you are creating a product, because the problem I think in AI is also that we are not learning from our mistakes. So for any good product to come out there, you should learn from the past mistakes, if a similar product has been created. So in AI we have good examples of things which should not have been done.
Mhm.
And then we thought, okay, you know what, the people, they would have learned from it and they are not going to repeat the same mistake again. And then we see after a few months it's the same in a different country, in a different setting. So in Netherlands, I think there was a algorithm which was discriminating between the immigrants, and basically it was finding people. So the idea was okay. The idea was to actually automate the stuff. They wanted to automate. So in Netherlands, a part of the income that you spend on your child care, it's reimbursed based on your income. And so people have to submit few forms, and they have to give proof that their income is below a certain amount, and so the state reimburses that amount to them. But of course there are some fraudulent cases, so the government, they automated the stuff and to catch the fraud claims. But unfortunately, the algorithm was picking up on, you could say, on a feature of dual nationality. So what it was doing is it would pick up all the people who had ticked dual nationality, which is essentially immigrants, and it would show them to be in high risk of committing fraud. And because of that, all those people, they had to return all the money that they had got from the state as part of their reimbursement. And this was like disastrous on a lot of account. A lot of families were broken. People even went to commit suicide because they had to return the money that they got for a few years. So this algorithm, I think, this was finally scrapped, but the damage had
Hmm.
already been done. And then recently there was a problem of robo debt, which was in Australia. This was also an algorithm by the government of Australia to catch, on a similar basis, to people who were indulging in fraud, with respect to their income. So they were tallying their taxation records, and they were tallying the money that people were getting from welfare schemes. So essentially, if you're paying a high tax, you don't need welfare schemes money. So there also the algorithm, it
Hmm.
just I don't know what it did. There also it was picking up on a proxy which was not correct. And uh, and if you just Google today about robodebt, you will see that the cases are still going on, and it had to be scrapped again. So I find these two pretty similar, but I think we didn't learn from our mistakes, and just after a few years, we see a repetition of this. So these kind of examples, I think, are the most dangerous one, where the public have no idea what is happening. It's just a black box. They have no idea. Unfortunately, they are the one who are the sufferers. I mean, that's the worst part of it. So if you talk to some technologist, and they at least know what's going under the hood, how the AI system is working, how the algorithm works, they might even question you. But there are people out there who have no idea what's going on, and you're using
Hmm.
an algorithm on that, and then they are the one who suffers. These are the, I think, the red flags, which we've tried to emphasize in the book, and examples like these.
So we've talked about high risk applications, like some kind of examples. How do you define high risk applications in the setting of AI and machine learning? We've seen a few examples, but I'm curious to hear if you have some kind of general definition. And the second question related to this is, once we've defined high risk application, what is the goal of the book? Like, what is the book about exactly?
So I would say personally, high risk applications in any application that has effect on humans, uh, and any application that affects humans in any way would be a high risk application. So for me, it's that simple. And then you can start categorizing, like healthcare would come under that. So if you're using AI in healthcare, it would come. If you're using AI in finance, it would come there. So things like that. And looking at the penetration of AI, I think soon all the applications would become high risk applications because of the way AI is advancing, and what sort of products. Because even if you look at recommender systems in Netflix, it's our data with that's going on. Then again, it's linked to humans. Um, so some way humans are always involved, and as the penetration of AI increases in our day-to-day life, I think it would be high risk. Even like facial face detection systems, biometrics, everything, all of them for me are high risk applications. And okay, and your
Sorry,
second
why
question.
why would Netflix algorithms be high risk? Why do you think this?
So my also one of the aspects of responsible AI would also be privacy. So responsible AI is this umbrella term, and it has various sub terms under it. So one is explainable AI, interpretable AI, cybersecurity, privacy. And going into the future, like, I don't know if, because it's your data that's going on, and inside the system is collecting your data for over so many years, and then what if you reverse engineer it, and then you can easily identify that who is the person staying in this corner of the world, and they can exactly pinpoint that it's you, and they know that you are there, and then they also um, put your other data, publicly available data that you have, right, from maps and everywhere, and then they know everything about you. You are this person, you go to this hospital, you work in this place, you watch this movies, and this is scary. It's right now, it looks like I'm talking about some high sci-fi movie, but it's really happened. In fact, so the president of America, they don't carry a mobile phone for security reasons. I think it was when Donald Trump was the president, but based on the mobile phones of their people around them, his location was actually identified. This was a, I forgot whether it was a New York Times article or a Washington Post article. It's a great article with a lot of visualizations, and they showed how privacy in the age of AI, it's an
Mm.
important aspect of it. So right now, when I when I sign up to any service and they ask me, you want to sign up through Google, or I think twice, should I be giving my data
Mm.
here? But you always leave a digital footprint, right, when you are online. So
Mhm.
privacy is another big concern that's happening, and you don't want people to monitor you all the time whenever you're connected to internet. So that's another aspect of it. And that's what I'm saying. In future, more all the applications might become high risk applications.
Okay, I see. Interesting. So even if it doesn't have like a direct impact, like on like healthcare or loans, where we can directly see the impact, there could be some algorithms, like yeah, any online algorithm that uses data based on your behavior that could also be risky in the future. That touches on your privacy,
I mean,
basically.
elections are being influenced, right? We've seen the Cambridge Analytica case,
Hmm.
where the so it's not like, it's not that's not happening. It's happening, but I don't know how much of it is happening today and how much we are part of it unknowingly. But this is also a field of concern, at least.
Okay, so what is the book about? Let's go back to this question. What is the goal of this book then?
So like I said, the book basically has two parts to it, and the first part basically covers the traditional model risk management and computer security best practices. So it's more theoretical in that area. So we talk about things like incident responses or bug bounties for AI. So bug bounties are a concept that you use for software engineering, where companies give bounties to people who find bugs in their software. But we've shown examples where the same could be used for AI models also. And also we emphasize upon like red teaming activities that you can do in your workflows. The second part of the book is very practical, hands-on, where we give you examples how to actually do that. How do you debug your model, uh, both your like traditional tabular data set and or your deep learning model. How do you actually red team this? And so it's generally, you learn in the first part and then you apply in the second part. And another important aspect of it is we've aligned it with the recent NIST AI risk management framework. So NIST recently came out with their AI RMF, that is AI risk management framework. And they've given, it's a voluntary, you could say, guideline for
Mm-hmm.
people or companies for creating AI products. It's voluntary for now, but we've tried to align our book with that. So like this goes with that section, and what other things you can do. So it's, you could say, the three important things: the theoretical aspect of it, of traditional model risk management and security best practices. The second part has hands-on code, and the third part is the alignment with the AI risk management framework. So it's that way.
Looking at the algorithms, what kind of algorithms should we use then for high risk machine learning? Is there a certain kind of algorithm that you would prefer. I don't know, transformers and deep learning or simple models that are explainable. Yeah, what's your take on this one?
Like, of course, if you look at the image and text, if you like, of course, maybe you can't say that you use simpler models for them. I've not even tried. And the thing is, for decades, people would say that, both ML practitioners and researchers would say that more complex the models, more accurate the models. So if you want higher accuracy, you have to go with complex models. And if you go with the simpler model, then you don't get accuracy. So there's always a trade off. So you can either choose accuracy or you can choose interpretability. But there was this seminal paper by one of the AI researcher called Cynthia Rudin. So there she actually showed that it's not that way. You can also get pretty accurate results with simpler models. So her paper was called "Stop Explaining Black Box Models for High Stakes Decision." This was the exact line of her paper, and there she showed how simpler models can give you accurate results when you're not like when you're not concerned with 0.0005
Hmm.
difference in accuracy, or you're not going by state of the art models, because in real life I don't think that would matter. So if a person has about 80% chance of you could say giving the loan or back, or you could say defaulting on the loan, and then there's another person who has 70% of chance on defaulting the loan, it doesn't matter, right, so much. uh, so for such high stake decisions, it's always advised to go for interpretable models, which are themselves, like, you can explain those models. So the category of them would be, so there we have models like additive models. So we have, those are called GAMs, or generalized additive models. So they are accurate, and they're as accurate as their counterparts like, say, XGBoost and LightGBM and so on. But unlike them, they are explainable. So you can explain them to another stakeholder. So why my model sort of made this decision. Uh, and Then there is another library called EBM, Explainable Boosting Machines. So explainable boosting machines are supposed to be a counterpart to gradient boosting machines. So gradient boosting machines are black box. You don't understand why decisions being made. But explainable boosting machines, by Microsoft Research, it's a model which is not only explainable, but it is as accurate as gradient boosting machines. So when you are creating models for high stake decisions, especially for financial aspect, it's better to go with explainable models, which are simpler and as accurate, or a little bit less accurate. But I don't think that little less accuracy actually matters when you're working in a high stakes decision. Um, if you talk about image and text based, of course, there are some simpler models. Like, for example, you could say protopinets. Like, people are working on simpler aspects of them. I don't know, right now we do have. So the only thing that you can ensure for such models is testing them, debugging them, and so on, till you have a simpler option available. But for financial models, and for tabular data sets, you have a very good option of simple models.
So yeah, that's interesting. So there are you're saying that there are some explainable model like explainable boosting machine, right? Is that the interpretable or explainable boosting machine? Um, that are basically perform as well, but can also be explained. That's yeah. I'm
Yes.
gonna share some links in the description. Now,
So,
regarding the
just
yeah yeah.
make it clear to people who don't come from this background. So the way you explain models or explain decisions of models is by two ways. So one of them is, you first train a model. You don't care about the model that you're using. You train the model completely, and once the model is trained, then you use some external techniques to explain the decision. So these are called post hoc techniques. So there it's model agnostic. It doesn't depend on the model that you're using. The other way is to pick up a model which itself is explainable. For example, if you take a linear regression model, you
Mm-hmm.
can look at the coefficients and you can explain that, right? You can take a decision tree, a simple one, and then you can see the rules, right? Why did this decision tree split at this point? So these are explainable models themselves. On the other hand, if you go for, let's say, XGBoost, you don't understand it, so then you explain them after they have been trained. You use techniques like SHAP and partial dependence plots and so on. There are lots of techniques. Then you use those techniques to explain why you think the model has made a certain decisions. So that's the two categories that you use.
So we focused on the model part, but what else could we pay attention to in a high risk machine learning setting? We talked a lot about the data previously. You mentioned also the testing phase. So, what are the other things that should be considered when talking about high risk machine learning outside of the models?
So I think the first would be definitely to uh, make sure that the data set, the sources that you're getting the data set from, they're not biased. The data set itself is not biased. For instance, normally we have a habit of course, testing a model by either looking at the AUC metrics, or let's say testing it on the test set or the holdout test set, right? And we look at that metric and we say, you know what, this is working. It's generalizing very well because it's working very well on the test set. The problem is, if you have a data set, instead of looking at over, like just like final result of it, you should look whether that metric is also working across different groups. So let's say if you have different populations in your data set, um, let's say you have different genders, for example males and females, you have to see whether that metric works for different. So if you have a 80% accuracy, is that 80% accuracy also reflected when you divide your data set? So
Mm-hmm.
that 80% should be for males as well as for females. So you just cannot look overall, like for my entire data set my accuracy is 80%. You also have to look at uh, population wise. Uh, so these way you have to go granular and look at these things. You have to make sure you've done enough testing for your, like you could say, once you create your model, it's tested enough, maybe on diverse data sets, which is like not on the same population, to see if it is working good, it's generalizable. You After you're done with that, you should also regularly audit your system. So it's not like once you already create your system and then it's working well, it's great. You have to regularly come and audit your system so that uh, your model is not failing afterwards. And other than that, I think red teaming your systems, like sometimes you have to act as an adversarial validations, and you have to test your systems from the point of view of an adversary. So you attack your systems yourself before others are going to
Mm-hmm.
attack them, and then you sort of try to find out what is the possible problem with it. So that's, I think, very important part of it. So those are some of the things that I think you can try.
Thanks. Yeah, that's super interesting. Actually, there are a few. Well, I work in a fintech startup, and so we do quite a lot of testing before releasing our models. We try to retrain our models quite frequently. But yeah, that's there are lots of great things that you share that I think a lot of companies should get inspired, and a lot of data scientists as well should get inspired and start testing basically every step of the pipeline. You should be quite confident in everything. You should think about everything, and yeah, don't just look at aggregate metrics overall, but really trying to dig further into what's going on in different parts of your data set to make sure that the product that you're releasing is actually working and is actually good. And it's first of all, it's I think it's a good thing for AI ethics bias, but it's also probably even a good point for your company because if you don't do all those checks, you're just releasing a model that doesn't work well, and in the end, I think you're gonna lose money. Like, you think you've got an 80% accuracy when actually, if you dig further, you've got lots of trouble, and your 80% is actually a 60%, and so 60% is worse than an interpretable model that gives you a real 70% accuracy. So not only for AI and ethics, but AI and ethics is obviously super important and probably the main driver. But the second thing is, even just for money for your company or for the impact that you want to make, if you don't understand your model is not going to work as expected, and you're going to be in trouble, basically.
Yeah, I think so the US banks, they have to undergo a stress test. And so what they do is, they have to test their models on data sets of, you could say, extreme behavior. So for instance, pandemic, so they simulate conditions of a pandemic, or they simulate conditions of a recession, so that if they are going to encounter such situations in future, the models don't break. And so this is, we've seen the pandemic situation actually. And a lot of models, they failed to predict COVID actually. So they undergo stress tests, and they have to actually undergo a stress test, and they have to simulate conditions. And I think this is also a good test for other companies also, to simulate, do stress testing for your models in conditions which are very extreme, and see if your model breaks, or it stays. So that's also a very good way to sort of make sure that you have a robust model.
So, what is your view on the future of AI then? Do you think we're heading in the right direction? Are you optimistic about the future, or do you think that things will just get worse?
Though, so I'm an applied data scientist, and I work with with models, and products which are based in AI. I think, like any other technique, this is still, I think, an upcoming field. This is just the starting or the beginning. But it's good that we're also hearing voices about regulations also. And it's not only from, you could say, ethicists or AI researchers. The government is also pretty keen on this, and I think a lot of government all around the world are bringing out regulations and guidelines just in time, before things just go out of hand. Uh, I'm very optimistic. I think we can really solve some of the problems which have been lingering on for decades, just by using the correct way, and working in a, you could say, in a more regulatory way, I would say, and just making sure that we abide by certain rules, so that we are not just sort of blown away by only the success, or we only see the good parts of it and we don't see the bad parts of it. We should look at both the pros and cons and then take decisions. I'm pretty optimistic about it. I think AI has the potential to make a lot of change in our lives. But yes, I think has to be done in a way that's useful for everybody, and not marginalizes or affects the people who are already being affected, the minorities. So it shouldn't sort of create a gap between what already, it shouldn't widen the gap, I would say. And because it's always the people who are at the lower end always gets affected, and that's true for AI and for any other policy in the world. The people who are at the upper end will always benefit from anything. So that we have to keep in mind. And one of the things that we can do to accommodate this is to have a diverse teams who are working on AI products. Start by having a diverse teams which has people from all different walks of life, and not only data scientists, I would say, people from, you could say, philosophy, people from economics, different people. That, I think, that's a good way to actually start this.
Yeah, thanks a lot. I definitely agree that diverse teams is also very important, and I actually discussed this in my previous episode with Marain. We also talked about diverse team. I think he has an astrophysicist in his team, people from different backgrounds and different genders, different cultures will bring different ideas to the team, And as
Yeah.
we said, this is good for AI and ethics, but it's also good for your company because you're going to end up with better projects if you, well, if you're, I think I saw something, a sentence like this. I don't know if it was on LinkedIn or somewhere, but if you just hire people who can do the same things, you're just going to be able to do one thing. But if you hire a diverse team, you're going to be able to do much more.
And they a lot of people, when we talk about diversity, they think diversity is just to rectify the ratio, and this they don't understand the underlying importance of it. Let's say if we are sort of collecting data set, and you only collect like images of just same population, and let's say I'm on the team, I would definitely point out, look, all these people, they don't look like me. I think you should also have people who look like me. So we should definitely change the data set, and then there'll be some other person from some other part. And that way, what knowingly or unknowingly, we are creating a diverse data set, which is in turn going to make our models more robust, which is going to end in the end also help our
Mhm.
product. So that's also the reading between the lines, which a lot of people don't. So yeah, I think like you said, diversity is really a key to sort of battling the biases in AI.
So let me just ask one question on your career overall before we finish the episodes. If you just had one advice for someone to progress in their career, what would it be if you just had one advice?
So I would say never stop learning, and never stop progressing in your career. And today, I think we live in a time where, thanks to internet, we have access to the best resources, uh, from the best in the field. So I would say, if you really if you didn't have the time early in your career to pursue something of your interest, and now you want to pursue that, I think it's like, there's no better time than this to do that. So I would also see, also embrace challenges. If you're especially in the AI field, things are changing at a rapid pace. Oh my god, like if you, for 1 week, if you're not on Twitter, you it looks like you've lost centuries there. But it's okay. I think we have a good community around that. Make sure to work with the community. It has a lot of power, and and just believe in yourself, I would say that.
Well, thanks a lot, Parul. It was great to have you on the AI Stories podcast. Have a great evening in India, and yeah, hope to catch up soon.
Thank you so much. It was a pleasure. Bye bye.